My name is Barabbas Lisi, and this is my Module 5, Assignment 5.1. In this exercise, what we're trying to do is determine if a set of bowlers can enhance their bowling scores by receiving 15-minute individual instruction by a bowling expert. So we've got two different sets of scores. We've got the game one that was bowled before they received the tutelage, and game two afterwards. So the first thing we've got to do is figure out the difference between the scores. And to do that, we'll go and hit transform. We'll go down to compute variable. We're going to type in DIF, which will be difference for the two. We'll move one of the variables over. We'll choose game two minus game one and hit OK. So we've received the differences in the scores. The next thing we're going to do is see if these differences in the scores are normally distributed. And to do that, we'll start with hitting Analyze, Descriptive Statistics, Frequencies. We'll move the difference variable over. We'll click on Charts, click Histogram, and show the normal curve. We'll uncheck Display Frequency Tables because we don't need that information. And hit OK. And we can see that it does look normally distributed, but we'll check a little bit farther to make sure, and we'll look at the Shapiro-Wilks number. And to do that, we'll go back to Analyze, Descriptive Statistics, Explore, and we'll move the variable over the difference. We'll click on Plots. We're going to check none for the box plots, uncheck the stem and leaf, and go to the histogram. And we're going to click on Normality Plots with Test. Hit Continue. And as we look at the Shapiro-Wilks score, we can see that it is 0.337, which is greater than 0.05, which means the data is normally distributed. So the next thing we're going to do is determine what the percentage difference is in those differences in the scores. And we'll do that by going to Transform, Compute Variable, and we're going to change this to percentage difference. We'll clear all of this out. We're going to type in open parentheses. We'll put game two minus game one close parentheses, and we'll divide that by game one. We'll close the parentheses, and we'll multiply that by 100. And we'll hit OK. And we'll go back into our table, and we'll see that next to the differences in the scores, we've got the percentage of those differences. So the last thing we'll do is we'll do a pair t-test to analyze and see if there is a significant difference. So we start off with hitting Analyze, Compare Means, Paired Sample t-test. We'll move the two variables over. Game one In the game two, we'll hit OK. And the mean between the two games is 90.00 for game one, 94.95 for game two. So you can see that went up. We'll also see that we've got a two-sided p-variable, but this isn't the test we want to look at. We want to go down to the paired samples test, where we've got our two-sided p-value, which is 0.108, and a degree of freedom of 19 with a t-value of negative 1.685. So does a 15, and this is me restating from the beginning what we looked at. Does a single 15-minute individual coaching session with an expert bowler enhance the student's bowling scores? That was the hypothesis, or that was the research question. The hypothesis is, the null hypothesis is that a single 15-minute individual coaching session will not enhance students' bowling scores. The alternative hypothesis is that a single 15-minute individual coaching score will enhance the student's bowling scores. The t-value is negative 1.685. The difference of degrees of freedom is 19. The p-value is 0.108. The means are from game one, 90.00. For game two, 94.95. The standard deviation is 13.541 for game one and 14.318 for game two. So there's a 4-point difference with a strong positive correlation of a strong positive correlation of 0.556. And that means that there is a difference and is a significant difference in the bowling scores. Thank you.